Hello everyone, I am Priyanka Patel and in this video I am going to cover measurement of surface and interfacial tension. If you don't know about principle of surface and interfacial tension, then go through my video regarding introduction of surface and interfacial tension. Link is available in description box. Kindly follow the link and first understand meaning of surface and interfacial tension and then come back to the video and learn about measurement of surface and interfacial tension. So, for measurement of surface and interfacial tension, there are different methods available. Choice of method mainly depend upon whether we need to measure surface or interfacial tension, size of sample we have available, and accuracy of the method. So, method for measuring surface tension and interfacial tension. First one is capillary rise method that can be used for measurement of surface tension only. Another is Ding-Dunoyer tensiometer. This can measure surface tension as well as interfacial tension. And last one is drop weight method or drop volume method. That is also called as stalagmometer method. So start with first method, capillary rise method. When we place capillary tube into water containing beaker, first water has tendency to wet the glass surface. Why it wet the glass surface? Because of adhesive force between water and wall of capillary, that is glass surface and water. Because of that adhesive force, water wet the glass surface and after wetting it, it starts rising into the capillary. And this is because adhesive force between glass and water is greater than the cohesive force between liquid molecule. The volume which rises up into capillary wall, it is equal to the surface tension of the liquid. So here upward component of the force is equal to the surface tension. So upward force is equal to gamma into cos theta. So this gamma into cos theta, here it is angle. This is the wetting angle between liquid and capillary wall. So gamma into cos theta and upward force is equal to 2 pi r gamma cos theta. 2 pi r is the circumference at any point into capillary tube. 2 pi r is the circumference of the capillary and gamma cos theta represents the surface tension. If we consider water or most of the pharmaceutical liquid, it completely wet the wall of the capillary. So the contact angle will be 0. So value of cos theta will be mostly 1. Same as upward force, there is also downward force. Downward force that will restrict or it will govern the movement of liquid. So if we consider downward force of gravity is equal to mass into acceleration and that can be given by pi r square h rho minus rho 0 g plus w. So pi r square cross sectional area of the capillary, h is equal to height of the liquid column to the lowest point of the meniscus. Rho and rho 0 is the rho 0 is difference in a density of water and its vapor. G is the gravitational, G is the acceleration due to gravity and W is weight of the upper part of the meniscus. At maximum point, both these force, upward force and downward force will be in equilibrium. So if we compare the equation 2 pi r gamma cos theta and pi r square h, this equation 2 pi r gamma cos theta upward force and pi r square h rho minus rho 0 into g plus w will have equation gamma is equal to half 1 by 2 r into h into rho into g. This is the equation that we derived when we discussed about pressure difference across the curved surface. So that is the practical application of pressure difference across the curved surface for the measurement of surface tension. So next is Ring-Dunoyer tensiometer. This method used for measuring surface tension and interfacial tension. The basic principle of ring Duno tensiometer is the force which is necessary to detach platinum iridium ring immersed at surface or interface is proportional to the surface tension or interfacial tension of the liquid. That means if surface tension is more, we have to apply more force to detach the ring from the liquid surface. As we have discussed in first video, that surface tension measures the strength of cohesive force. So if it is having stronger cohesive force, the force required to detach the ring will be also higher. And same we have discussed in a soap film, that if we don't apply the sufficient weight to the movable bar, we won't be able to break the soap film. So here also same principle is applied. The force which is necessary to detach platinum iridium ring immersed at the surface or interface, it is proportional to the surface tension or interfacial tension. In fact, the calibrated dial measures force as well as the weight of the liquid which is pulled when we pull this ring from the surface of the liquid. The surface tension can be calculated from equation gamma is equal to dial reading in dials 2 into ring circumference, that is 2 pi r. Why it is multiplied with the 2? Because if we consider ring, the water which attach with the ring, it produces two surfaces, one inside and another one is the outside. That's why it is multiplied with the 2. And another one is the correction multiplied with the correction factor. Why correction factor is necessary? Here correction factor include radius of this ring, radius of the wire which is used for preparation of this platinum iridium ring. So depending upon the different radius of the wire or radius of the whole ring, it leads to change in a dial reading. So to avoid that correction or to avoid that differences in a reading, correction factors are added. If we don't add correction factor, it may produces error up to 25%, and by multiplying it with correction factor, we can also reduces error up to 0.25%. So next method is drop weight method. In drop weight method, we use instrument called as the stalagmometer. So stalagmometer is basically glass capillary which consists of a bulb like a structure, and when we allow to flow liquid from one mark to another mark, and if we count the weight or if we count the weight of a drop or if we count the number of a drop, we can measure the surface tension of a liquid. This method can be used for measurement of surface tension. So when we allow the liquid to pass through a capillary like structure, first is produces a drop, and that drop gradually detach from the tube. When it detaches from the tube, weight of the liquid is equal to the surface tension of the liquid. So m1 into g is equal to 2 pi r into gamma. This equation is for the test liquid. The one of the limitation, or you can say, for measurement of surface tension with this method, we can measure the surface tension of unknown liquid with respect to the reference liquid. So we have to measure the uh, we have to perform the experiment for reference liquid as well as for the test liquid. So m stands for the mass, g for the acceleration due to gravity, 2 pi r is the circumference of the capillary, and gamma 1 is surface tension of the test liquid which we have to find out. Same as that for the reference liquid, weight of the drop that we measure when it detached from the capillary, g again gravitational force 2 pi r gamma 2. Gamma 2 is surface tension for the reference liquid that we already know. For example, surface tension for the water. So we can find out surface tension of unknown liquid with respect to surface tension of standard liquid, for example, water. So when we divide equation 1 with the equation 2, we'll have equation m1 divided by m2 is equal to gamma 1 divided by gamma 2. And if we put up the value of all these three parameter, we can find out gamma 1. So this is drop weight method, same as that of drop volume method. So in drop volume method, we have to count number of drop that is produced with specific volume of liquid. So volume of one drop of test liquid we divide by N1, same as for reference liquid we divide by N2. So if we consider this equation, m1 into g is equal to 2 pi r gamma 1. In this, if we put up the value of mass, that means mass density is equal to weight by volume. So mass is equal to volume into density. So here we have converted the mass terminology, or we have written mass terminology in form of volume into density. So we divide by N1 into rho 1. Rho stands for the density of the test liquid, 2 pi r gamma 1, and same equation for the reference liquid. So we need to find out the density of, we need to find out the surface tension of test liquid. So when we divide equation 1 with equation 2, we'll have this equation, and this equation can be used for measurement of surface tension of test liquids with some of the standard pharmaceutical liquid, for example, water. We can determine number of drops of test liquid and reference liquid, density of test and reference liquid. We have value for surface tension of reference liquid, and after putting all this value we can find out gamma 1. So basically drop volume method and drop weight method is used for measurement of surface tension of test liquid with respect to the reference liquid. Now next topic is spreading coefficient. So what is meaning of spreading coefficient and why it is important? So we'll discuss what is application of spreading coefficient, but first we'll see what is spreading coefficient. So if we consider that if we place some liquid like oleic acid on another layer of liquid like water, it will spread as duplex film if adhesive force is greater than the cohesive force. That means if force of attraction between oleic acid and water molecule is greater than the cohesive force between two oleic acid molecule and cohesive force between two oleic acid molecule, then it will spread as a duplex film. So if it does not have greater adhesive force in comparison to the cohesive force, it will not produce film. It will retain on the surface of water as a droplet or a globule only. Why the term duplex film is used over here, not a simple monomolecular film? Because film is sufficiently thick and we can differentiate surface and interface. That means when oleic acid will spread, surface will be oleic acid and atmosphere, and interface will be boundary between the oleic acid and water. So thickness of the film is sufficient enough that we can differentiate surface and interface from each other. So as you know that surface and interfacial work is equal to surface tension multiplied by the change in a unit area. That means W is equal to gamma into delta A. So this portion indicates, or this is called as the sublayer liquid. That means if we consider this is the water and this is considered as the spreading liquid, which is denoted as the L. For example, this is oleic acid. So when the force of adhesion is greater between oleic acid and water, it will produce duplex film. So if we want to separate this oleic acid layer again from the sublayer of the liquid, we need to apply work of adhesion, and that work of adhesion is the energy required to break the attraction between two unlike molecules. If we consider that cross-sectional area of this cylinder is 1, because surface or interfacial work, that means delta W is equal to surface tension multiplied by unit area change. So here work of adhesion, if we consider the cross-sectional area of the cylinder is 1 centimeter square, this term will be 1. So work of adhesion is equal to gamma L plus gamma S minus gamma LS. Gamma L stands for the surface tension of spreading liquid. That means oleic acid. Gamma S stands for the surface tension of sublayer of liquid. That means, for example, water. And gamma LS is the interfacial tension between two liquid. So this is called as the work of adhesion. So here, to separate the oleic acid molecule from the water molecule, that means, or to separate the film of oleic acid above the sublayer of water liquid, it consists or it is affected by surface tension of water, surface tension of oleic acid, and interfacial tension of oleic acid and water both. So same as that work of adhesion, there is work of cohesion. What is meaning of work of cohesion? Work of cohesion is energy required to separate the molecule of spreading liquid. That means here we have considered spreading liquid as the oleic acid. So amount of force which is required to separate the molecules of oleic acid. If molecules of oleic acid does not get separated, that does not produces film over sublayer liquid, for example on water. So this work of cohesion is amount of work which we require to break the attractive force between oleic acid so as it can spread over the surface of the sublayer liquid or it can spread over the surface of the water molecule. That is called as the work of cohesion. And as we perform work of cohesion, it produces, for example, for this cylinder, if we break it, it will produces two different surface. So work of cohesion will be 2 into gamma L. Again, we doesn't have considered surface area over here because we have considered surface area is 1 centimeter square. So 2 into gamma L into surface area. So surface area is 1. So spreading occur if work of adhesion is greater than work of cohesion or work of adhesion minus work of cohesion is greater than 0. Then only spreading occurs. So what is meaning of spreading coefficient? Spreading coefficient is difference between work of adhesion minus work of cohesion. So WA minus WC, this terminology is called as spreading coefficient. So spreading coefficient, we have put up equation for work of adhesion and work of cohesion over here. So finally we have equation gamma S minus gamma L plus gamma LS. So gamma S stands for the surface tension of sublayer of liquid. Gamma L stands for again surface tension of spreading liquid, and gamma LS is interfacial tension between spreading liquid and sublayer of the liquid. So this equation indicates that if value of spreading coefficient is positive, then only spreading takes place. That means it is necessary that value of gamma S should be greater than gamma L plus gamma LS. That means in simple language, surface tension of this spread sublayer of the liquid, it should be greater than the surface tension of the uh, spreading liquid and surface interfacial tension of spreading liquid and sublayer of the liquid. In simple language with example, if I'll tell you surface tension of water, which is considered as the sublayer of the liquid, it should be greater than the surface tension of oleic acid and interfacial tension between oleic acid and water. If does not so, then oleic acid will fail to spread on the surface of the water. That means oleic acid will spread, but if we consider any of the liquid which is having surface tension greater than water or sublayer liquid, it will not spread as a film, but it will remain floated as a lens, as you can see in the diagram. So when value of this surface tension of the spreading liquid and interfacial tension of spreading liquid and sublayer liquid is greater than sublayer liquid, value of spreading coefficient will be negative, and that makes the lens type of structure on the surface and it does not produce its duplex film. So this is all about spreading coefficient. So next topic is spreading after equilibrium. Whatever we have discussed till now is about initial spreading. But what happened after equilibrium? So what is meaning of equilibrium over here? So when spreading takes place on sublayer of liquid, at certain point there will be a mutual saturation of liquid. That means sublayer of liquid becomes saturated with the spreading liquid and spreading liquid saturated with the sublayer of liquid. And when this happens, that leads to change in a surface tension of both the liquid. So if we consider the new surface tension of liquid after mutual saturation, it is denoted with gamma S dash and gamma L dash. Sometimes initial spreading is maybe positive. So that leads to spreading of liquid over a sublayer of liquid. But after mutual spreading, that spreading coefficient becomes negative or it reduces, and in that case the initial spreading of liquid may occur, but it is followed by coalescence of excess material and that is converted into lens form. So that is called as the reversal of a spreading, when surface tension of sublayer of liquid reduces and it becomes less in comparison to the surface tension of the spreading liquid and interfacial tension of sublayer liquid and spreading liquid. Now, what are the factors that affect the spreading coefficient? So, first one is the molecular structure. In that, first is greater the polarity of molecule, more positive spreading coefficient. For example, ethyl alcohol or propionic acid. If substances are non-polar in nature, for example, liquid petrolatum, it have negative spreading coefficient, so it fail to spread over the water. Next is in substance, for example, oleic acid or organic acid, greater their carbon chain length, that leads to decrease in their polar characteristic. So that decreases the spreading coefficient. For oils which are having more polar group, for example COOH or OH, in that case their spreading is good. Next is cohesive forces. So example for cohesive forces is spreading of benzene over water. Benzene doesn't spread on water because of its cohesive force, because of its polar, but it spread because the cohesive force of attraction between two benzene molecules is weak in comparison to the adhesive force between benzene and water molecule. Next one is application of spreading coefficient in pharmacy. So practical application of spreading coefficient in pharmacy is for the coating of the tablet, that is for film coating, spreading of solution over a tablet surface, and another is spreading of semi-solid preparations over the skin when we add surfactant to it. So with this I conclude my video, and in next video we'll discuss about adsorption at liquid and solid interface.